Okay, so maybe we can get started. I think there's a fair bit of people who've already joined. So it's my pleasure to welcome you all to the first session of the Practitioner track, which is going to be kicked off by Nitzi. Nitzi has studied at PUC, Rio de Janeiro, where I did a Portuguese course at some stage in my life. So that's quite wonderful to see that on your CV. And Nitzi's now with SAS, and she's going to talk about large-scale new product forecasting via machine learning. Again, that's a topic that I'm personally quite interested in. So I very much look forward to your talk. Nitzi has agreed to give to take questions in the last 5 minutes. Yeah, and then the stage is yours.
All right, thank you, Tim. Good afternoon, everyone. Good morning. I don't know exactly because we are all in different time zones, but I'm glad that you're here with me today. I will share with you our experiences in the area of new product forecasting. And on that note, I would like just to start with a brief introduction on this topic, right? So no doubt it is a key task. New product forecasting or forecasting the demand for new products is a key task. Companies need to forecast demand for new products way before the products are launched, right? Months, sometimes months, other times weeks, it depends, to guide different business decisions, right? So it could be pricing decisions, purchasing decisions, inventory, and so on. The problem is because they don't have any historical data on those new products, how can they have an idea of how that product will develop in the marketplace? How can they forecast those new products? So it's really a big challenge. And I would like to highlight some of the challenges around new product forecasting. So first of all, we are talking about forecasting the early life of a product. And there is a lot more uncertainty around that time frame than once the product is established in the marketplace. Second, because there is, as I said, companies need to forecast ahead of the launch. There is no demand signal, no historical data on the new products. Then that is a big challenge in itself. How can they forecast? At least statistical forecast methods will depend on having historical data, right, to forecast. For that reason, it's common that a lot of judgmental techniques are applied in this area, which has its own challenges in itself because there is human bias, right? We are all human and we have our own biases and preferences and et cetera, et cetera. So that is another problem. Not only that, if you think about it, even in judgmental approaches, you want to forecast a new product, what you're probably going to do is you're going to look for similar products that were launched in the past with similar launch conditions, and then try to infer from those historical products how your new product will do. Problem is you may not have just one, you may have multiple similar products, right, to choose from, which one to use. And to add to this, products with short life cycles are even more challenging because you have more and more products in that category recently, right? As products don't stay forever in the product lines, and new products are always introduced. So short life cycle products are even more challenging and in more quantity, right? So there is really a large number. At the end of the day, what we see is that there is increased number in new product launches. And that, again, brings a lot of challenges in terms of using judgmental methods or methods that are not automated, especially when we are talking about operational forecasting problems, where now we are talking about forecasting at the product and location levels, which is really detailed levels, and then, it's a large scale problem, right? So when we talk about new product forecasting, there are different types of products that are introduced as well. Not all new products are the same type. So just as a reference here, we have products that are similar to existing products, and they are basically the same, right? Maybe a cereal that changed the box, but the content of that box is still the same product. So the consumer will experience the same product. It's just a layout on the box or some packaging differences, small differences like that. That doesn't really bring any innovation to the product. So those we refer to refinements, right? Refinements to existing products. Then you have, on the opposite scale, you have the new to the company or new to the role type of products, right? We just experienced that with the COVID vaccines. How can you forecast that? And then you have maybe the product is not new, but it's being introduced in new markets or it's given new uses. And then you have the line extension. So now it is a new product that is being added to the product line. It is bringing some innovations, but it's not completely different of everything that was launched in the past, right? So it's adding to the product line, competing with the existing products, but bringing in some innovation at the same time. So because you have different types of new products introductions, you do have also different types of forecasting techniques that are more or less appropriate depending on the type of new product, right? And I have listed some here on the right-hand side. Of course, I will not cover them all. We don't have time for that. I do have some references in the back end of the presentation where you can check on some very good reviews on new product forecasting techniques and approach used to address those different types of new product introductions, okay? What we will focus on today, though, is on one particular approach that we have been using in the following situation. So this approach is focused on the forecast of new products ahead of the launch. So it's a pre-launch forecast when no single identifiable historical product is available. So there are multiple products that may be used as approximations of this new product in the forecast analysis, right? Examples are, fashion goods, toys, books, movies. There are many different examples in that space. And we are forecasting large scale. So we are talking about operational level forecasts here, okay? So how can we solve this problem with an approach that will provide a high degree of automation, right? With some statistical rigor, math, driven by data and math, right? And less judgmental. That's the focus, okay? So let's take a look at what that may look like, what this approach looks like at a very high level. We approach this problem in two ways. So we split the problem in two. So if we can predict the pattern, the shape of the early life, right? And we can predict the total volume of early life, there you go. We can forecast a new product. So we split the problem in two, right? And we create models that predict the pattern and models that predict the volume. And those predictive models are using attributes from the product, the location, the launch, attributes that are known about the new product to be launched, right? That's all we can use in terms of inputs in those predictive models, because that's all we know about the new product, okay? I'm not being totally honest here. Actually, we do have some more information, which is the historical demand data on the historical products that may have similar behavior to your new product. So we also leverage that in this process, right? So in the pattern prediction step, we are looking at the early launch pattern for the historical data, clustering that data, finding if there are common patterns, right, in the early launch. And then based on those patterns, we have this model that will assign your new product to the pattern clusters, right? So what we use is a combination of statistical methods and machine learning to come up with to be able to predict the pattern and predict the volume. I'll talk a little bit more in detail how we do that in this next slide. So this is the analytical process overview. starting from the left side, we have the data that is available to train and build those models, right? So we have the historical early life of demand of the historical products. And we have attributes for the products, the launch conditions, the locations or customers, depending on your level of analysis. We prepare the data and we create then the historical early life data. And instead of working with time series, with time index, we will work with a cycle index. So we align the early life of the historical time series to the same cycle index, right? Which is cycle 1 of the life of those products. And that's what we refer to the cycle series. So those cycle series then is what we will use. We'll compare and create the pattern clusters, right? Well, in terms of the data preparation, so that's what it is about, creating those cycle series, the pattern, which can be represented in different ways, like the profile, which is basically the contribution for every single time period up to the total volume, right? And that is what we can use to determine the patterns, the early life patterns. And we also work with the attribute set. We typically enrich the attribute sets. We do some feature engineering and so on. Well, now that I have prepared the data, I will start with the pattern prediction, which is the top part of the flow. So we form clusters of products with similar life profiles. And by profiles, I mean let's say I'm working with monthly data, monthly time interval data. So the profile means, and I'm forecasting the first year of life of that product. Then the profile would be the 12 factors, right, or the percentage of allocation of the total volume for the year, for the first year, to each cycle in that first year. Okay. That is then what we cluster. We cluster those profile series. And we use for that, what we use is k-means and hierarchical clustering methods. Of course, there are other techniques that can be used, but that's what we have been using. And we use them in combination when we are doing this segmentation analysis with many thousands of time series, right? We use a combination. We do k-means first, just to reduce do a first reduction in the number of clusters, and then we apply hierarchical clustering on top of that. Well, once the clusters, the pattern clusters are identified, now you end up with a limited number of patterns, right? Then what we need to do is really now how assign my new product to a pattern, right? And to do that, we use a machine learning model. We are using random forest model to assign the new product, looking at only the attributes, because that's all the information we have for the new products. So we train this model to predict the cluster assignment, right, for the new product using attributes. Now I find what is the pattern cluster. I have identified that pattern group for my new product. Now I will model the pattern. Basically, you estimate now the profile based on the members of that cluster, right? And there are different ways that you can estimate this, but a median is a simple example of how you can form that final profile prediction, right, for your new product. That's the pattern prediction piece. Then we have the volume prediction, the total volume prediction for the early life period that we are forecasting. Well, here again, we are using different techniques. We are using regression, we are using random forest and neural networks to predict the volume, using again attributes as inputs and predicting the total volume. And then we do an ensemble of those predictions, and that is our final prediction of the total volume, right? Now with the total volume and the pattern, we can then generate the final forecast. Then the we multiply the two, right? And we have now your forecast. However, there is one step final step that is aligning, adding back the time index, because we have been working, as I said, in a cycle index, and now we need to go back to the time index. Okay, I'll quickly show you an example using some real data. So this is a case study on Apparel company. This company sells many different types of products, shirts, pants, bags, belts, etc. They sell their products through their own stores or through other retailers. So there are different channels, and there are many different customers that they work with. So their goal was to optimize. Their problem was they needed to optimize the inventory at their distribution centers and also their buying plans for new products. And so we implemented this approach for them, and we observed some very good results in terms of improving the accuracy of the forecast at the product customer monthly level, right? So we reduced the relative error, the median absolute relative error. We reduced the variance in the forecast error as well as the bias. And most of all, besides the accuracy improvement, we also help them with providing a more efficient monthly demand forecasting process, because they have to run this every month. There are thousands of products that they need to forecast, including new products, right? So at the end, we could automate the new product forecasting and integrate with their existing larger forecasting problem, right, and process. Quickly here are some of the attributes that we used in this analysis. There were not too many, I would say, which was a challenge in itself, but we had some product attributes, brand, category, style, color, stuff like that, the fitting code, the style, the fabric, the planned lifespan. So not all products had the same lifespan for this customer. So within the 1 year horizon that we had to forecast, some products only lasted maybe 4 months, right? As an example. But we have that information ahead of time, so we could use that as an attribute as well. There were very limited attributes on the customer side. So we only know who their customer was and the grouping of the customer that it pertains to, and the channel and the region. But that was it. And we had the launch date, and we did not have price or promotion data. What we had was this price category, which is a relative price within the product category, an indication of that. Right? So that's in terms of attributes. In terms of historical volume, time series data, we were working with customer orders, right? So we had 4 years of monthly customer orders, and we have the planners or the planned volume history as well. Okay, so here's an example of what the series, some examples of new launch data, new product launch, early life data looks like. I have the top volume ones here. And this is what I was referring to, the cycle series. Now I'm aligning all of these 8 time series in the same cycle index. So everyone starting with the first period of life, right? So that we can compare the profiles, which is the next step. After we align through the cycles, then we create the profile series. So we had about 2,800 historical new launches over this 4-year periods, and we of course did the training and validation test data splits and so on for creating the models. And then we run the cluster analysis on the patterns on the profile series, and we obtain like 6, in this case, for this subset of the data. I'm not showing you the whole data, of course. This is a subset of their data, one of their product groups that we are looking at here. We ended up with 6 patterns, right? Or 6 clusters of early life patterns. So you can see that some are pretty flat, not very interesting, pretty, stable ordering pattern, versus others that, they order a lot at the early stages of this first year, and then it goes down quite a bit, right? And this one is stable with some, more movement towards the end of the cycle. And, you have some variations here. So this one, they order a lot more also at the beginning. And here there are two major reordering cycles. And this is one that basically order everything, almost everything, at the very first period, and then very minimum towards the rest of life, or the first year of life, I should say. Okay.
Nitzi, sorry, we're 22 minutes past the hour. Just want to give you that heads up.
Thank you. So of course, there are other types of clustering variables that can be used, but for this example, we use the profile series, okay? Now, in terms of pattern prediction models, here are some test results for that. We use the random forest classifier here, and of course, the results are not great. We obtained a 60% misclassification rate, but it's still an improvement over the random classifier, right? If we were to just randomly select a sign based on the cluster frequency, we would have a even worse classification rate. So it is an improvement over that. Not great. There's more work here, but limited attributes. That was kind of what our conclusion in terms of what we could do for the pattern prediction model. Now, for the volume prediction model, the story is a bit different. We were obtaining better results, and we tested different variables, and I'm showing here some testing of that, and how, as we added more meaningful attributes, we improved the performance. And we did one test too, which is, okay, we have the specialist forecast. Why not include that in the forecast and see if that even helps improving it even more, which it did. So for the total volume prediction, then at the end, what we observed comparing against the specialist forecast and the baseline forecast that we defined through an heuristic approach of selecting the most similar products and then just averaging the volume for the most similar products and attributes. We did perform better than the two, of course, not as much as the planners because it's close, but better. In general, we improved, as I said, the bias is greatly improved, as well as some of the accuracy, right? And this is then the final forecast. So when we applied all of these models together and generate the final forecast, as you can see, this is an aggregation for all products. The light blue line is the machine learning based approach, and the purple line is the specialist forecast, and the actuals in black here. So pretty shapes are closed, volumes are not too far, so very decent result at the end of the day, and we were even improving over the planners when we combine all the models together and generated our final forecast. And this is a zoom in one of the products just that you can see the comparative results. Okay, just wanted to touch quickly on some practical considerations here, things that I didn't cover in that, but things to think about while we are setting up these types of approaches, right? So first, you don't throw everything in the sink. You typically will split your analysis in some sort of segments, right? Business defined segments that make sense. So you wouldn't want to use belts to forecast, I would say, shirts, right? As an example. So we did a segmentation approach to combine or use historical data for products that made sense to be used in a bigger sense. So attributes are key. This approach will not work if you don't have attributes, and attributes that are meaningful, that are predictive, right? So need to dig deep and get those attributes and transform, right? Do some feature engineering as well. Like different lifespans, that is a challenge in itself, and you need to come up with different ways to tackle that problem. Seasonality is also another feature that you need to, in the pre-processing, we typically take care of that. We remove seasonality and then we add it back again in the final forecast, and so on. So in conclusion, I mean, this approach did show some good results in some work we did for different customers. I showed you one case study, but we have been implementing it in different industries, in retail, CPG, and manufacturing, with some good results, similar type of results. And it is fully automated, which is good because, as I said, in a large scale forecasting, this is a requirement, right? We need a fully automated method. So I think that concludes my talk. If you do have, here I have the references for you. And if you have any questions, I will be glad to address right now.
Thank you, Nitzi, for your talk. If there are questions from the audience, can you unmute yourself maybe and switch on your camera when you ask the question, please? Maybe while we're waiting for a question from the audience. Oh, sorry, Hussein.
Yeah, so thanks a lot for the very interesting talk. I was wondering, also tying this to your tutorial from yesterday, Tim, about global forecasting models, like how do you see the link between these two in the future? Like, because global forecasting models can also be used for this cold start problem in certain instances, and what you showed was exactly an application of that as well. So how do you see the link?
Yeah, so I would say this is an area of active research for us, and we are exploring the use of deep learning models for new product forecasting as well. Problem is, again, it's going to be heavily based on attributes, so hopefully it will help us with some of the challenges that we are having here, with, for instance, the pattern prediction, right, and the attributes, and creating more complex relationships that we cannot, just do the future engineering for. So we use random forest, gradient boosting, and regression models heavily here, not the deep learning models, but I definitely see the application here for sure.
Thank you.
Thank you for your talk. So I have one question here. So you have shown some patterns that commonly have been observed. I'm wondering, how did you come up with a pattern for each cluster group? Like how did you aggregate different time series, early profile of them, to get some kind of a clear pattern that somehow shares within group?
Yeah. So given the cluster, right, then you have multiple time series, early time series in that group, right? So your question is, how do I get to the final pattern for
Exactly.
that group? Yeah.
Yes.
So here I would say we use the median, we use the mean, we do typically, but there are other ways that you can combine those in your final prediction, right? One point that is important is, and that's how we feel about this. We don't want to have just one way of doing things, because depending on the data, depending on the situation, you may need to use a different way to combine the time series within the cluster, right? So there's not a unique way. There are many ways techniques that you can use for that, and including the other models as well. We use 3 models for the pattern prediction, but you might want to use something else, right? So the important piece here is that you have this analytical framework. This is about an analytical framework and an analytical process that have those key steps in there, and then you want to have the flexibility to use the techniques that make more sense for your data, for than the business.
Thank you for your answer.
Yeah, and with this, I want to thank you, Nitzi, for your talk, and for everyone for the questions.